Alright, in this video I'm going to talk about section 5.4 from the book. Okay, in the last section we learned about how to find the Laplace transform of the solution of an ordinary differential equation with constant coefficients, and after that we learned about the inverse Laplace transform, and then we did some examples on how to find out inverse Laplace transform of a function, right? So here we will use Laplace transform and the inverse Laplace transform to solve the initial value problem. That's what we are going to do here. Okay, so let us see some examples, or basically the idea here is to find out the inverse to solve a differential equation. What we do is we first take the Laplace transform of the differential equation, both sides, left side and right side of the differential equation, and then you solve for the Laplace transform of y. Okay, and after you do that, you find out that you take the inverse Laplace transform. Okay, after that you take the inverse Laplace transform. Okay, so you may have to do some partial fractions there, but the idea is first take the Laplace transform and then you solve for the Laplace transform of the solution and then take the inverse Laplace transform. Okay, let us take this example. We have y double prime minus 10y prime plus 9y equals to 5 times t. Y at 0 is -1 and y prime at 0 is 2. So you take the Laplace transform on both sides of that. What you get? You take the Laplace transform of the first term and then you take 10 out and then find the Laplace transform of the y prime, and then 9 times Laplace transform of the y equals to 5 times Laplace transform of the t. So you use the formula of the Laplace transform of the second derivative, which is s squared Laplace transform of y minus s times y0 minus y prime 0, right? Minus 10 times the Laplace transform of y prime is s times Laplace transform of y minus y0 plus 9 times Laplace transform of y equals to, what is the Laplace transform of t? It is 1 over s square, right? Because what is the Laplace transform of t to the n? It is basically n over s to the n plus 1, right? That's what you get, right? N factorial over s to the n plus 1. This is the Laplace transform of t to the n when n is the integer, right? N is the integer. So here now what we want to do is we want to solve for Laplace transform of y. Okay, that's what we want to do next, solve for Laplace transform of y. So we need to factor out the Laplace transform of y from these three terms. You see that? If we take Laplace transform of y out, what is left? It's s squared minus 10s plus 9. S squared minus 10 times s plus 9, right? And see here, what is the value of this one? So y at 0 is -1, so negative s times -1 is positive s, and y prime at 0 is positive 2, but there is negative y prime at 0, so -2, and then negative 10 times negative y prime y0 will be positive 10 times -1, right? Because what is y at 0? Y at 0 is -1, right? So this is negative times negative is positive, so negative 10 times positive 1 will be -10, and equals to 5 over s squared. What you do next is you you subtract s and then add 12 on both sides. If you subtract s and then add 12 on both sides, so that will cancel out, right? And then this will cancel out with that. So what do you get? You get, if you simplify that, you will get s squared out, right? So you will get 5 minus s to the cubed plus 12 s squared, right? This is what you get from the, because there is 1 in the numerator, so you just write the same denominator. Least common multiple of these three things is just s squared, and then divide the s squared by s squared is 5 times 1 minus s times s squared, right? And then plus 12 times s squared. That's what you get. Okay, this is the right hand side. Now what you do is you divide by s squared minus 10s plus 9 on both sides. So if you divide by that, you will get divide by s squared minus 10s plus 9, and then find out the factors of this will be, because this has a 1 in the denominator, this is like top fraction times the reciprocal of the bottom fraction, right? That's what you get. So 5 times 12 s squared minus s cubed over s squared times s minus 9 times s minus 1. This is what you get. Okay, so what we want to do next is, since we solve for Laplace transform of y, we want to solve for y, right? So we need to take the inverse Laplace transform. But before we take the inverse Laplace transform, we want to get the simplified form of the right hand side. We want to use the partial fraction. How do I use the partial fraction for this? To use the partial fraction, you do a over s squared, right? As plus b. Let's do that way. As plus b over s squared, because there is the first s squared, this is quadratic, so you need to write as plus b, plus c over s minus 9 plus d over s minus 1 equals to, you get 5 plus 12 s squared minus s cubed over s squared, and then s minus 9, and then s minus 1, right? This is how you do the partial fraction. Now next what we do is, you want to combine these three fractions. So write the product of those three, s squared times s minus 9 times s minus 1. So in the right hand side you have the same thing, s plus 12 s squared minus s cubed over s squared, s minus 9, s minus 1, right? Now what you do is as plus b times, so look at that, if you divide this by s squared, what is left is quantity, right? Because if you divide this by that, the s squared and s squared will cancel out. What is left is s minus 9 and then s minus 1 plus c times, divide the denominator by that denominator, what is left is s squared times s squared times s minus 1, right? And then plus d times s squared times s minus 9, exactly the same way. Divide this denominator by that denominator, what is cancelled is s minus 1, what is left is s squared times s minus 9. Now you multiply by that denominator on both sides, so that will cancel out. So what is left is as plus b and then s minus 9, right? S minus 9, s minus 1 plus c s squared times s minus 1 plus d s squared times s minus 9 equals to s plus 12 s squared minus s to the cubed. Okay, so our goal here is to find out the value of a, b, c and d. All right guys, so let us, how do we do after this is, we select different values of s, right? So let us take, suppose you take s equals to 0. If you take s equals to 0 on the left side and right side, what do you get? This will go to 0, right? This will go to 0, so you'll get b times negative 9 times negative 1, right? So b times negative 9 times negative 1 will be 9b. You see that? Equals to, what do you get here? So this will be s equals to 0, implies this will be 0, this will be 0. So the first term will give you 9b equals to 5. So what is the b? B will be basically, you get b is basically 5 over 9. You see that? So this b will be 5 over 9. All right. So similarly, let us plot s equals to 1. So s equals to 1 implies, if I plot s equals to 1, this term will be 0, because this is 0 times something. This is 0, this is 0, what is left is this one, right? So d times negative, d times positive 1 squared is 1. So d times negative 8, right? So you'll get d times negative 8, negative 8d equals to, I am plugging in 1. So it will be 5 plus 12. It's 17 times 1 is, so 12 times 1 is 12, minus 1 is 11, right? So this is 11 plus 5 is 16. So 16. So what do you get? So you get d equals to negative 2. You see that? So I got b equals to 5 over 9, d equals to negative 2. So this is 5 over 9, d equals to negative 2. Similarly, you plug s equals to positive 9, will give you the value of c. Okay, so if you take s equals to positive 9, then you will get c equals to, this term will go to 0, this term will go to 0, right? So this will give you 9 square is how much? 81, right? Times 8. So 81 times 8. So that will give you, on the left side you will get 81 times 8. Okay, on the left side you will get, so when you take s equals to 9, you will get 81 times 8 and then c, right, equals to, if you plot 9 on the right side, what do you get? 5 plus 12 times 9 square minus 9 to the cube, right? Let me find, and then you will get C equals to 31 over 81. This is what you get for C. Similarly, so to find out the value of A, there is nothing to left that cancel one of the term, right? So you can take S equals to 1. You will get A equals to 50 over 81. So you get these values, okay? So now what you do after this is you plug these values here, and you will get the Laplace transform of the right hand side as these terms, okay? So after you simplify this into the partial fractions, many fractions, okay, what you do, you take the inverse Laplace transform of this. So what you do, you take inverse Laplace transform. So the inverse Laplace transform, so what you do here is take the inverse Laplace transform, the left side will be just yt, right? What you do next is you pull the 50 over 81 out, and then inverse Laplace transform of 1 over s is just 1. So the first term will be 50 over 81. Second term, you pull the 59 out, inverse Laplace transform of 1 over s square is t, because the Laplace transform of t is 1 over s square. That's what you get. Similarly here, what do you get here? Let us write down that. You put 31 over 81, and then you do inverse Laplace transform of 1 over s minus 9, right? So do you know that Laplace transform of 1 is 1 over s, right? So but Laplace transform of e to the t, and then times 1. I multiply both sides by e to the t. So you will get 1 over s minus 1, right? That's what you get. So if you get 90, then what you get is s minus 9. So that's what you want to find out, that, right? So this will become 31 over 81 e to the 90 times 1. That is e to the 90. So e to the, next one you will see that here. So that the integral, the inverse Laplace transform will be e to the 90. You see that here, right? So similarly, you can do negative 2 pull out 1 over s minus 1. The inverse Laplace transform of that will be e to the positive t, right? So that's why you get negative 2 times e to the positive t. Let us see another example. That example has 2y double prime plus 3y prime minus 2y equals to t times e to the negative twice t. And y at 0 is 0, y prime at 0 is negative 2, okay? So what you do, as usual, you take the Laplace transform of each of the terms, and you plug in the formula of the Laplace transform here, right? Of the second derivative, Laplace transform of the first derivative, and do that. What you do next is you collect the term with the Laplace transform, this term, and this term, and then that term, and then take that Laplace transform out. This is the remaining thing there. And there is, so this value y at 0 is 0, right? You see that? Y at 0 is 0. Now y prime of 0 is negative 2. So this will be negative times negative will be positive, but there is 2 times that will be positive 4. You see that? And this is 0, right? Now this one, you see that, what is the Laplace transform of t? So Laplace transform of t is 1 over s square, right? But if you multiply by e to the at, then it will be s will be replaced by s minus a, right? If you multiply by multiply this function by e to the at, then the answer will be 1 over s minus a. But we need s, we have negative 2 for a, right? So it will be s plus 2 squared. That's what you get on the right side when you take the Laplace transform, okay? Now what I want to do next here is I'm subtracting 4 from both sides. You cancel that one, so you'll get 1 over s plus 2 square and then minus 4. I have to combine these two fractions, okay? So how do I do that? So there is 1 in the denominator. You can just think like multiply those two, you got that, and then just do the cross multiplication. You can think that way, right? So 1 minus 4 times s plus 2 square. If you simplify this, what is s plus 2 square? S plus 2 times s plus 2, right? That will give you s square plus 4s plus 4. But there is negative 4 outside. So that will be negative 4 times that is 1 minus 4 square minus 16s minus 16. But there is plus 1. So that will be negative 14. So every other terms are the same. So that's the right hand side. You see that? That's the right hand side. Also, what are the factors of these two? Why do I need to find the factors here? Is because we'll have to take the inverse Laplace transform to find out the inverse. To find the inverse Laplace transform, we want the denominator in the form of the factor, right? Because since we will be dividing by this on both sides, so it is better if you write in the factor form. So to write the factor form, I write the first term as it is, last term as it is, and I want to divide I want to break the middle into two terms so that the product is product of these, right? So the product must be negative 4s squared and the sum must be positive 3s. So what are the pieces that multiply to negative 4s squared and add to 3s? That will be 4s and then negative s, right? So 4s times negative s is negative 4s squared, 4s plus negative s is positive 3s. That's what I'm going to do. After that, what you do is you group the first two and then last two. Okay, so if you group those two, you factor out 2s. So s plus 2, that is left, and minus 1, there is nothing common, so I took negative 1 out, so what is left is s plus 2. So s plus 2 is common, so I took the s plus 2 out, and then 2s minus 1 is the remaining one. So this is the factor of the left side. Okay, so what we do next is we divide both sides by those two product of these factors. So what you get is you get, so the right hand side, this is that thing, right? And then you will be dividing by this quantity, that means 2s minus 1 times s plus 2. So you will be dividing by 2s minus 1 times s plus 2. That's what we are doing here. You see that? But see here, s plus 2. So there is s plus 2 and then s plus 2 is square. So you can even combine that to s plus 2 to the cube because that's the product. So 2s minus 1 times s plus 2 to the cube. So the next thing you do is use the partial fraction to get the to separate those factors there, okay, in the denominator. So how do I do the partial fraction? Let us look at that. So I take all these here and then see, since these are the repeated factors, what do you do? A over the first non-repeated plus b over the first exponent and then plus c over second exponent and then the d over third exponent of that, right? That's what you do, and then you just simplify that. So just combine those, just make the single denominator, right? Just take the least common multiple of those, and this is what you get. Now if you say, for example, s equals to negative 2, then what happens is this will be 0, this will be 0 because that term will be 0, and this will be 0, but this is non-zero, right? So you will get 2 times negative 2, right, is negative 4 minus 1 is negative 5d. On the right side, on the left side, if you plug in negative 2 for s, you will get negative 4 times positive 4 because negative 2 squared is positive 4, and then minus 16 times negative 2, right, minus 15. If you simplify this, you will get negative 16 plus 32 minus 15. So negative 16 minus 15 is negative 31 plus 32. So basically 1 on the left side. So if you solve this, you will get d equals to 1/5. That's what you get there, right? Similarly, one of the things you should be careful on this is, look at this. If you set s equals to 1/2, positive 1/2, then this will go to 0, this will go to 0, this will go to 0. You will get a equals to this value. Okay, so s equals to positive 1/2 give you a equals to that. But I don't want to keep this 2s minus 1 form. Why? Because the inverse Laplace transform needs s minus something or s squared minus something, s squared plus something, that form. We don't like anything before s, right? Any number multiplying x, we don't like that too. So what I did, I factor that out. If I took 2 out, then it will look like 2 and then s minus 1/2, right? And then that 2 will cancel with that one, and you get negative 96 over 125 times 1 over s minus 1/2. That's what it is. And similarly, if you take s equals to 1 and s equals to 2, you will get the value of c and b. Okay, so value of c and b will look like this. Now, so this is in the partial fraction form, so it is in the simplified form. So what we do next is we will take the inverse Laplace transform. Okay, so here, what is the inverse Laplace transform of this term? We know that the Laplace transform of 1 is 1 over s. So if you multiply by e to the positive 1/2 t, then you will get 1 over s minus 1/2, right? Because we know that Laplace transform of e to the at times 1 will be what? 1 over s minus a. Look at that. Because the Laplace transform of 1 is 1 over s, but if you multiply by e to the at, we do s is replaced by s minus a. That's what we are doing, right? So what you get here is a is basically 1/2, right? A is 1/2. So it is basically the integral of the inverse Laplace transform of this is negative 96 over 125. This will be e to the positive 1/2 t. That's what we get here. Okay, similarly for the second one we have s plus 2, so it will be 96 over 125 and then e to the positive twice t. sorry, negative twice t, because it is positive here. It is positive, so we need negative twice t, right? And then minus 2 over 25. What is the inverse Laplace transform of this? This will be, we know that the Laplace transform of Laplace transform of t is 1 over 1 s plus t square. 1 over s square, right? The Laplace transform of t is 1 over s square, but we have s plus 2, so we need to do e to the negative twice t, right? You see that? 2 over 25 t times e to the negative twice t. Similarly, the last one is 1 over 10 t squared times e to the negative twice t. So this is how you solve this differential equation.